Hi there, I have a question.
Please.
So I wanted to go back to the thing about in the notch delta model about iterating over the neighbors and the thing where it said common surface area.
I'll
What I
turn
wanted
it
to,
back to Josh then. Okay,
yeah,
Josh, you want a screen share?
Yeah, 1 second. Let me let me get that part here.
yeah. So I thought that's what I didn't understand is whether, in fact, as it's been written, the program it is actually using that feature, or some additional code would have had to be put in to take advantage of that feature. Because it seems, from a physiological point of view, that is a good feature. Because if two cells are in contact with each other, it's only the delta that is on the surface of the adjacent cell which is in contact, that is relevant to the amount of notch signaling that a cell receives. So rather than counting all the delta that is in the neighboring cell, just what's in the contact area should be important. So is that what the way it's written it's doing it, or does something additional need to be written for that to happen? I can't.
So
Yeah.
yeah, so it the when the for loop it's iterating over right, the get cell neighbor data list gives you that information, so it's already available to you. Whether you decide to use it, as I mentioned, it's up to the user, right? So for example, we could have divided where we have df there,
Yeah.
we could have divided by that variable common surface area,
Ah.
because that would make sense, right? And that's what I was explaining earlier. It
Yeah.
would make sense that if that your the how much of the delta it's contributing to the signal depends on what the common surface area is between the cells, because these are
Correct.
cell surface
Correct.
receptor, right?
Correct.
Uh,
Correct.
so it would make sense to divide the common surface area by that, at least in this particular example. But it's available to you because the for loop is already iterating both over the neighbor, the reference of the neighbor, and what is the common surface area between your cell and the neighbor. So yeah, it's available to you.
Okay. Thanks.
Mhm.
Other questions, comments? Um, I realize that iterator over neighbors is sometimes confusing because people aren't used to seeing an iterator that returns a tuple. And so it looks funny to have two arguments in the loop. But it's quite a powerful feature when you use it. There were some questions in the chat about converting them, having trouble with one of the things one does have to be careful about is depending on where you've installed CompuCell. If you run a demo, you need to make sure that you have write access to wherever CompuCell is going to try to put its output. And so that can be a bit of a problem. Sometimes it can be confusing for people. So you do have to remember to set your target directories to be something that you have write permission for. Tomorrow, we're going to start out with what would have been the last talk today, which is going to be on MABOS integration of CompuCell to do stochastic Boolean network models. Then we'll have two talks on links to do convergent extension and epithelial tissue folding, which are going to be very relevant to the hackathon ideas. And then we'll have a final talk on parameter scans and data export, and parameter files, and model building. And so I hope that works. If people are still having trouble running the antimony integration with the CompuCell, please do contact us, and we'll do our best to get a patch out for CompuCell. PJ, do you have any suggestions, final suggestions for what to do?
I mean, we've tried a couple of solutions that we've had intermittent success with, but I'm still getting reports from people who are not finding those solutions successful. So the surefire way that we do know of that's available to everyone is to migrate over to the NanoHub tool. So, you know, in the module that we do on MABOS, for example, there's a bit of additional installation work to do MABOS and CompuCell locally. So in that module, I'm going to ask everyone to migrate over to the NanoHub tool, if only for that module. But if you just don't want to waste time on trying solutions and things like that, then I would strongly urge you to use the NanoHub tool. And then of course, use the functionality to migrate your simulations to and from their servers in your local machine.
Josh, there was a question. AJ, do you still have a question, another one, or is that for the one you already asked?
Sorry, I should put my hand down.
No, it's just I wanted to make sure. So there was a question in the chat. Josh, I don't know if you want to discuss it. There was a question about, it says if you have more than one compartment of a cell, how can the products from one compartment link to the other compartments?
So, so the way we define compartments is by creating, new cell types, and then we basically tied the two different cell types, and then we call that a compartmental cell. And it would follow the same principle as we were doing before, where you load, let's say, one antimony model in a particular cell type, will correspond to loading it into a compartment of a cell, and then you can link it the same way we've done it so far, linking between different cells, but instead linking it inside a single cell. I don't know if that answered the question. So basically, yeah. So basically, it follows the same principle as linking between different cells, because in principle you treat the two compartments as if they were different cell, what we call cell objects.
That would be a good exercise to try. You could try it.
That's what I was thinking. Never tried it before. It would be an excellent demo to have.
Any other questions? Okay, so I hope it works. If it doesn't work the way you expect, we'll find a workaround for it. Any other comments, suggestions? I know it's been a long day. I appreciate people's patience with the issue with the Windows installation. Great. Okay, well, I guess then we're done for today. If the instructors could stay on for a minute, that would be great. If there are additional questions, well, you're welcome to ask them.